Hi lads, how's it going? So today we're going to have a look at properties of materials. Okay, so there's going to be two sections that we're going to focus in on for this. The first one is you'll see it on the top of the sheet here. It's the type of forces. Okay, so when we're generally speaking about wood, even plastic, metals, anything to do in woodwork or construction, those materials are going to be coming under certain types of forces at different times. Okay, so we're going to be having a look at that. The second little section that we're going to be having a look at is examples of materials which are good under certain circumstances. So we'll say hardness, density, toughness. These are properties of materials which influence our decision to pick wood in a certain situation, possibly metal in a different situation, and plastics in a different situation. Okay, so this is really important because you don't want to be using wood in an environment where it's not suitable. All right, so this video, lads, is going to be a little bit shorter because there's not as much information in it. All right, so as well as having a look at types of forces, we're going to use this video just to develop our sketching a little bit. Okay, so the first force that we're going to be looking at is compression. Okay, I have that one sketched out. All right, but before we start looking at compression, I'm just going to quickly run through how I want you to draw these rectangular, I suppose, cubes, and how I want you to alter them to show the force which is coming on the cube then. Okay, so to begin with, guys, we'll have I suppose a little bit of this done in Woodwork before. Okay, I want you to start by creating a crow's foot. All right, so start with your vertical line when we're sketching. All vertical lines remain vertical. From the bottom point, I'm going out at roughly 30 degrees to the right and 30 degrees to the left. All right, so when you're sketching, guys, you can rotate your page around if that makes it a little bit easier for you. So this is our crow's foot, 30 degrees to the right, 30 degrees to the left. And then every line is going to be parallel to those two lines. All right, so we should only have 3 lines on our page. Just a little bit off. We should have vertical lines, lines to the left and lines to the right. All right, so just do these lightly because we're going to be going over these again to show the different types of forces. All right, so that's one created. Again, they don't need to be perfect. Just try and get the general shape some way correct. So as you're going through this, lads, you can pause this video and resume it at any point or any stage that you want. Okay, so you should be pausing it fairly often. All right, so before we continue to have a look at this, I just want to show you some real life examples of these types of forces. So the first one is compression, second one tension, third one bending, fourth one is shear, and the last one is twisting or torsion. All right, so okay, so just some examples of this, right? So the one that you're going to be most familiar with is the new bridge and the New Ross bypass. All right, there's a lot of forces in play in this bridge. All right, but the first two that we're going to be viewing are compression. So compression is basically when you're pushing your two hands together. So you can see the spring here. The force is coming in from both your left and right hand to squeeze up that spring. Okay, an example of compression in the workroom would be if we're using clamps to clamp our project, keep it pushed together, or even the vise on the workbench. When you squeeze up a piece of wood in that vise, you're putting the compression on your piece of wood within the vise. All right, so compression is the first one. You can see compression, guys, in the concrete pillar running straight down through the spans in this New Ross bypass bridge. All right, so the weight from the top here and the weight from the very bottom, there's a force coming down from the top, and there's a force coming up from the bottom, and all that concrete is in compression. Okay, so concrete is a material which is really good in compression. That's why it's used. All right. So the second force that we're going to be looking at is tension. The example of tension here, lads, is a tug-of-war rope. Okay, so you can see there's a bit of rope. There's two lads pulling it, and they're trying to pull that rope apart. All right, so I suppose the one that's been in the news lately is James Keogh pulling tug-of-war and up for the Great Exactlead Award. All right, so when you're pulling the tug-of-war rope, the tension on that rope is coming from both ends. Okay, so you can see here that the rope, eventually, if it does break, that's because the tension is coming from the left and also from the right. If we come back to the New Ross Bypass Bridge, the example of tension on this is the steel cables which are holding up the middle of the bridge. So you can see that the large spans here, the middle of the bridge is being held up, excuse me, by the steel cables coming from the top of this central pillar. Okay, those steel cables are in tension and they're being pulled apart. All right, and steel is really, really good in tension. Okay, so when the pressure comes on this, the steel goes into a force of tension and it holds the middle of the bridge from dipping or falling down. All right, so they're the first two. The second one is bending. All right, bending is one that we should all be familiar with. Okay, if you get your ruler, your steel or plastic ruler, push both sides in, the middle will bend out. If you get a hurley and put a little bit of pressure in the middle of the hurley, not too much pressure because you don't want to break it, the middle of the hurley will bend. Okay, so bending is one we're all familiar with. Shear. Okay, so shear is one that we possibly are not too familiar with. All right, so a shear force is basically where you have, let's say, a block of wood here, a block of any sort of material, and one, I would say, the top of this material is going to the left, the bottom is going to the right. Where that breaks across the middle, that's a shear force. Okay, so you can see here with the blocks of concrete, there is pressure coming in this direction at the left hand side, pressure coming towards us on the right hand side. They will shear off. All right. Another example of shear, guys, is your scissors, possibly. Okay, so the scissors is pushing up at one side and pushing down at the other side. That's shear. Look, something simple as if you had a bar of chocolate and if you had a good hole to it at both ends, and if you broke it in half in a kind of an up or downward manner, that's going to be a shear. Okay. The last one we're going to look at is twisting or torsion. Okay, and that's basically where you're catching something, we'll say, with your two hands. You're twisting your two hands in opposite directions, and that's putting it into a torsion force. Okay, so you can see an example here, and again an example here, right? So I suppose with wood, guys, a torsion is a tough kind of a force put on it because it probably will break. So that's probably not a good example. But if you were to think of a very light metal, okay, you could twist a very light metal into a torsion force. All right, so there are types of forces, and we'll just come back to our A3 page. All right, so we're going to sketch these out now. So the first one is compression. All right, you can see my arrows here are showing the direction of, or the type of force that's coming on this block of, it can be a block of anything, wood, metal, whatever it is, it doesn't matter. So the force is coming from the top down and from the bottom up. Okay, so the next one is tension. All right, so tension is going to be pulling it apart. So what I want you to do is I want you to create this block to begin with. Okay, because the tension, I'll just put in my arrows for the direction of the force. It's pulling it apart. So remember, tension is the tug of war rope, pulling from both ends. Okay, so the force is going to cause this to maybe buckle or bend up a little bit. So what I'm going to do is I'm going to put a small little bend into these. Okay, so if you think of a tension, it's going to be making that material or that block a little bit narrower. Okay, so all I'm doing is I'm putting a little bit of a curve in there to try and show that the material is narrowing down as it's being pulled apart. Okay, so the middle is narrowing in as it's being pulled up from top and down from bottom. All right, so that's tension. Bending, okay, bending. The classic example of bending is a hurley. Okay, so an ash, or a hurley is made out of ash, which is a very flexible material. All right, and look, basically, this is just going to be bending from the top to the bottom. Okay. Again, the reason the hurleys are made out of ash is because they are so flexible. All right, they come under, I suppose, a lot of strain at different times, and they need to be flexible. So if they're made out of material which is rigid, they would just break very often, very easily. Okay, so that's our bending. The forces for the bending one is there's going to be two forces coming here, the way that I'm after drawing this. Okay, and there's going to be a force coming out against it in the middle. Okay, so that force against it in the middle, that's going to cause the bending. All right, the next one is shear. Okay, so the shear is the scissors basically in what we were discussing. And with the shear, all right, it's the fact that you have a force coming in from one side, and opposite that, you have a force coming in from the opposite side. All right, so we have two forces coming in here. And I'm just going to show this at a little bit of an angle. All right, so I'm just going to pull this over maybe here. And I'm going to show this coming down at an angle rather than coming down straight. Okay, the angle, guys, is just to show, sorry, that's too steep of an angle. The angle is just to show that the forces which are being applied are putting a lot of tension or a lot of pressure on your shape or your material, and that's why it's eventually going to break. Okay, so look, that's, yeah, it doesn't look too bad. It's not too bad, all right? So pressure coming in from the bottom, pressure coming in from the top. The example here is, I suppose, the scissors, or if you're breaking your bar of chocolate, all right? So I'm just going to put in a few examples here. So this is a hurley, just to rejig your memory. And the tension is a tug of war rope. I'll just put in a rope, actually. Compression is a spring, okay? We'll just say a spring being pushed from both sides. Okay, so if you just put in that example so that it might rejig your memory when you're looking back at it into the future. Okay, so the last one is torsion or twisting. Okay, so this is going to be a difficult one to draw. I'm just going to bring it down here and kind of show a curve. If I can do that, I'm going to try and copy that curve around. And this one here is going to be curving this way. Okay, so look, I'll zoom in this here, just try and copy this some way similar to what I've done. Okay, all you're doing is trying to create the illusion or the image of the piece coming into torsion or twisting, which is basically when we have two hands together and if we're twisting something. All right. This will be curving back over here. All right, so the example for this one we'll say is a twister. Not the chocolate bar, the ice cream. Okay, so that's a similar shape to the ice cream you're going to get. So hopefully that might rejig your memory when you're looking back over this. All right, so that's the first half of this complete. All right, I want you to sketch these out nice and neat. Okay, work on your sketching when you're doing this. Do it lightly to begin with and go over afterwards with a heavy pencil. Okay, so I just want to put in this force around here. So just twisting force and again coming this way. Twisting force here once again. All right, so now that's those complete. The next thing, guys, we're just going to have a really, I suppose, a quick look at, and we're just going to take a few bullet points in it, is some examples of properties of materials. All right, so we've looked at types of forces. Now we're going to look at some examples of properties of materials. Okay, so on this, we're going to focus in on 10 different properties that will be common enough to us. All right, and I suppose 10 different properties that are going to be important in woodwork, metalwork, or even construction. All right, so the first one is going to be hardness. All right, so hardness is, I suppose, a really important one in woodwork or in construction or in anything where you're going to be making stuff or building stuff. All right, so So hardness is so important because if it's coming under a lot of pressure, a lot of different, I suppose, exposure to weather, wind, or any external factors, hardness is going to, I suppose, prolong the life of whatever material that you choose. All right, so I'm just going to put in a few examples of something which hardness is a really good property of. All right, so concrete is what I'm going to put in here. All right, so concrete, an external material which is used in really harsh climates. It's used around the ocean. It's used, I suppose, in all sorts of construction. And hardness is a really good property of concrete. All right, so when you think of hardness, concrete is the example I want you to think of. They're going to have a really long life. All right, so the lifespan of concrete is extremely long. All right, and as it ages, it only gets stronger. All right, the second one is going to be density. All right, so density is going to be important when you're going to need, I suppose, a lot of weight. All right, so when we think about density, we'll think of, I suppose, something that's going to have a really dense, something that's going to be heavy is rocks, gravel, like a block of wood is not going to be too dense, but I suppose different types of wood will have different types of densities. Okay, so just on that, a hardwood is going to be more often than not, a hardwood is going to be heavier. And a softwood is going to be lighter. Okay, so look, hopefully you can read my writing. I'm talking through it anyway, so you should have a good idea of what we're discussing. The next one is toughness. Okay, so the toughness of a material reflects the ability of a material to absorb energy. All right, so ash is another example of a tough wood that will not crack under a load. Okay, so if you're thinking about toughness, the opposite of toughness is brittleness. All right, so glass will be an example of material that's very brittle. When that comes under stress or comes under a load, it's going to break. Okay, so when we talk about toughness, guys, it's the ability to withstand, I suppose, and absorb a lot of energy. All right, so I'm just going to put in ash here as our example. I suppose withstand forces, or when I say energy here, guys, I mean, so with energy, I mean slaps, bangs, I suppose every day to day stresses which a piece of, I suppose, a hurley even can come under. Okay, the next one is elasticity. Okay, elasticity is basically flexibility. So how flexible is that material? Again, the easiest one here, lads, is ash. All right, so when we speak about wood, ash is a really flexible material, and again, that's why it's used in hurleys. Durability is the next one. Durability is material's ability to resist the effects of weathering, corrosion, and decay. Okay, so I'm just going to put in resisting weathering. 1, 2 is corrosion. 3 is decay. Okay, so examples of that, of where that is really important, guys, is if you were making an outside bench for home. All right, the durability of that wood is going to become really important. If you're using a soft wood which does not have good durability, um, it's not going to last long outside there in the weather. It's going to have decay. It might be corroded. All right. So if you're thinking about a wood which is really good outside, if you think of a hardwood like teak, that's going to have a really long life outside, especially if you put a finish on it, and it's going to withstand the weathering, the corrosion, and the decay a lot better than a softwood. Okay. The next one that we're going to have a look at is insulation. Okay. When we speak about insulation, guys, all right, the thing that comes to mind straight away is insulation in houses. All right, so the ability to maintain heat in the house is probably the first thing that might come to your house or your mind when you think of insulation. Okay. On top of that, guys, all right, so electric wires are covered with rubber or plastic because they do not allow the wire's electric current to pass through. Okay, so when we talk about insulation, insulation around wires will be an example of that also. Other materials that may insulate heat, like fiberglass, so that's like our insulation in our houses. Light, so when we talk about insulating light, that be your curtains at home. When you close your dark curtains, you're going to stop that light coming in. When we talk about sound insulation, you're looking for insulation to stop the sound. All right, so if you think about two houses which are side by side, you want materials between those two houses which is going to stop the transfer of sound. Okay, so I'm just going to put in, we have houses that's heat. I'm just going to put in insulated cables. So that's electricity. And finally, sound. Okay, so sound is the one where we have the two detached houses and we don't want the noise from one house passing the other. So we have to get a material which has good sound insulation values. Okay, the next one is ductility. That's basically how well a material can be stretched. Okay, so when we talk about ductility, we'll just put in stretched here. Okay, that's something, guys, that we're not going to be encountering too much in woodwork. But if we think of metals, okay, it is very common in metals. All right, so let's zoom in there. So when we talk about copper and lead, they can be stretched, they can be shaped into different, I suppose, forms, into whatever you want, really, I suppose. They have really good properties in that area. Okay, so the next one we look at is malleability. All right, malleability just basically indicates, once again, so very similar to the last one, once again how a material can be changed into different shapes without cracking. All right, so the without cracking is a big one here. Okay, all right. Plastics can be molded. When you heat the plastic, that can be molded into different shapes. All right, so when you speak about recyclable plastic, that goes back in, is heated and is put into different shapes. Look, something as simple as blue tack is a really good example of something that's very malleable. All right, so it can be bended and moved into different shapes. Okay, so 2 seconds there, guys. Just have to plug in the laptop. So the example I'm going to put in here, guys, is blue tack. All right, so that's something that we're all fairly familiar with. The next thing is color. Okay, when it comes to color, that's something that's really going to affect the appearance of a project or a material. I have an example in 2 examples in the book open here, just to show you how the color of the wood affects the overall appearance of a project. All right, so this is just a little table, and we have a kind of a carrier basket here, where you can see that the darker colored wood contrasts very well with the lighter colored wood. Okay, you can also see here, guys, that the malleability or the flexibility of the wood for the handle was a really important property in the wood that allowed it to shape like this. So when we're thinking about a wood that's really flexible, that would allow something like this, ash is probably our go-to. Okay, so the last one we're going to look at here, guys, is water resistance. Okay, and when we're talking about water resistance, we're looking at using woods internally or externally. All right, so when we're choosing a material to use outside, okay, we want to make sure that it has a very good property or a very good water resistance property. Okay, we don't want to put a material out there which is going to rot and decay in 6 months to a year's time, because that's not a good use of materials. Okay, so when you're finished, guys, just zooming back out here, your sheet should look a little bit like this. Types of forces up the top, some examples of properties of materials down the bottom, just a few bullet points to make sure that you can remember it into the future, and some examples of different properties within materials. All right. So thanks very much, lads. We'll leave it there.